All right, I'm just going to make this one a smart pilot problem. It will hopefully not take all 15 minutes like the last one, but we're going to go through a smart pilot problem here. So just a little bit of background, the problem flying a helicopter from ALO, which is Waterloo Airport, to Mason City, that is a bit of paying tribute to Mr. Strike, who was our former head of the math department. He just retired a few years ago, but anyways, yeah, he flew helicopters for our local Army Reserve. He was in the Army for something like 30, 40 years. So he did help write a few of these problems. So you'll see that regularly. So let's get down to the brass tacks here. We're flying a helicopter from Waterloo to Mason City. What we know is the heading is 310. So we know the exact ground direction we need to go, and we know how far it is. So we know the ground information. We also know that the wind is from 80, so we'll get to that in a little bit, going 40 miles an hour. We want to fly directly to Mason City in exactly 30 minutes. So what we need to do is figure out what is our ground speed, right? After we take into account wind pushing with us or against us, we know that we need to leave Waterloo, start a stopwatch, and 30 minutes later exactly, we are in Mason City. So if the overall trip is 61 miles, and we need to do that in 0.5 of an hour, what that really gives us is 122 miles per hour. So we know that according to the ground speed, we have to travel at 122 miles an hour to get there on time. We also know the heading that we need to go after the wind has pushed us or pulled us, whatever you want to call it, headwind, tailwind. We know what direction we need to be going after we account for wind. That is why this is a smart pilot problem, is we are in control of our destination. We're not just letting the wind take us wherever we want. We are actually going to know our destination. So what that looks like, again, on paper here, on a map, what we know is our wind. Let's go with wind. That's pretty easy. Well, sort of easy. It says from 80 degrees. All right, so let's break this down. The wind is from 80 degrees. Remember, that's a bearing. So when we do a bearing from 80 degrees, well, let's find 80 first. So from north, we're gonna go, well, here's 90 degrees from north. Straight east is 90 degrees. So we're just shy of that. So from 80, that's kind of poor, but I need to exaggerate a little bit because we need to represent that there's a 10 degree there. But I'm doing it as a dotted line because that's where the wind is coming from. And so, that is terrible. I'm sorry. I gotta shorten it up, right? Because the length of my arrow does represent kind of the magnitude of it. So again, we've got that 10-degree reference angle from 90 degrees. We're just 10 degrees short, so that will also represent that. That'll come in later, but at least we have our wind on the map here. So we also have the heading. This is where we need to go. So I'm going to draw that as P plus W. P plus W is a heading of 310. Well, north is 0, 90, 180, 270, 270. I'm 40 more degrees up. So I know I need to go something like this. That's a little exaggerated. Okay. Right, so there's your direction in terms of the heading of the airplane itself. So that's where we have to go. Now, if you think about it, if I need to go the direction of green, but if I just headed the direction of green and wind pushed me, I would end up further west. So what I need to do, I'm going to put this in blue. I need to point my airplane something like that originally, so that once I hit the wind and the wind pushes me, I will eventually get myself over to Mason City. So let's see, we've got, well, here's P. We don't know anything about P right now. We don't know the magnitude, we don't know the direction, but we know some stuff here where that's P plus W. So again, what I encourage you to do is always write it out. P, like vector P, vector W, and vector P plus W. So here we have, unfortunately, I'm going to start with P, which is just a bunch of unknowns. Then we account for some wind. And again, now we need to do a little bit of work, right? We need to figure out 10 degrees, yeah, 10 degrees. So again, when we write the vectors in component forms like this, we have to go back to using direction and using the positive x-axis as 0. So in order to get the angle for our component form wind vector, we need to know that angle right there. That angle is 10 degrees more than 180. So again, when you write vectors using this x cosine, y cosine, or y sine, we say the magnitude, which was 40, times cosine of the angle. And the angle, again, has to start at the positive x-axis. So in this case, that's 190. The y is 40 times sine. And let's see, checking my work. Yep, one. There you go. Now let's move on, and we go to our last vector, our P plus W vector. And what do we know about the P plus W vector? That's the one that we have. Our heading is 310. Our speed was 122. So our vector is 122 cosine of your angle. Well, again, that's a heading 310. Remember that gave us this like 40 degree. I believe it's 40. Yeah, 270 plus 40, that's 310. Okay. So we have this reference of 40 degrees, but we need to go from the positive x-axis. So that's 180 minus 40, or 140 degrees. Okay, looks like we've got all three vectors laid out. We know what we know and we know what we don't know. So when we look at this and we're saying, okay, how do we find P? Well, look at the vectors. We have P plus W. What's to say we can't say vector P plus W minus W? Does that not get us vector P? Right? So there you have it. We just got to take the math the other way. We got to take it backwards from what we did in the last problem with the dumb pilot. So let's do that. You can write it out in black here. So we need to take, well, I guess I should do it in blue because we're finding vector P. Well, 122 cosine of 140 is the P plus W x. So we take that minus 40 cosine of 190 degrees. And here's what I'm going to do. I'm going to pause for a second. I'm going to pause it because what I want to do is rewrite these two vectors as the decimal approximations. So give me 1 second. Boom. There you go. All right, so while I was paused, like I said, I just took the values and approximated them so that we can look a little bit easier at these numbers. But if you think about P plus W is pointing up and left, so the x component should be negative, the y component's positive. And it turned out that way. If you run the numbers yourself, check that you get those same two numbers. The wind, however, is pointed down and left, so that the x is negative and the y is negative. So all the numbers match, all that good stuff. So let's do this. Let's take P plus W minus W. So we take negative 93.46 minus negative 39.39, and we get negative 54.06 approximately for the x, and 78 minus negative 6, we get 85.3. So our resulting plane vector, it's not the resulting, it's the initial plane vector, is negative 54, positive 85. And if we look at that, that matches. We have a negative x, positive y, so that does represent the image pretty well. But we're still not done. Like we have the vector in component form, but that doesn't help us with the heading or the indicated airspeed. So we have to find magnitude of vector p. Well, that's just simply the square root of the first component squared and second component squared. And again, I simplified those with no decimals. Please don't do that in your calculators. But what you find is that the absolute value p, the magnitude, is approximately 101.05 miles per hour. So I will box that in because that is what the speedometer, if you will, inside the airplane, it's going to tell you you're doing 101 miles an hour, even though on the ground you're actually doing 122 miles an hour. So that has to do with the fact that the wind is mostly sideways, but a little bit of a tailwind. So now we need to know what direction that is, what heading that is, excuse me. So what we need to do is we draw our triangle. So I'm going to draw negative 54, positive 85. So that's that 54, that's 85. I'm going to find this angle alpha, tangent alpha. And what you find is that angle is 57.65 degrees. But again, that's not, first of all, I apologize, that is not shown very well here. That should be closer to the P plus W, but nonetheless, the alpha angle, that is, that's here, right? That's the 57 degrees because we use the negative 54 up 85. So we found that 57 degree angle, but the problem is we need to use heading. So really heading would be going from north all the way around until we get to that P vector. Well, we know that what that is 270, right? If we go back around here, 90, 180, there's 270 plus 57. So we just got to do 270 plus 57.65 degrees, and you say the heading would be 327. I'm just going to round that to 0.7, 327.7 degrees. So airplane heading, in your airplane, your little compass is going to show 327 degrees, even though after the wind, you're actually heading 310. Your ground speed, on the ground, you have to be doing 122, but what's nice is this wind is a little bit of a tailwind, so you only have to be showing 101 miles an hour. So there you go. There's a smart pilot problem. Thank you for listening. I told you it'd be less than 15, and it's going to be by about 5 seconds. But anyways, good luck, and I will see you guys tomorrow.